Hello everyone, my name is Chen Yijie. Today I am going to teach the Chatelier principle. First, the definition of the Chatelier is when the balance system is damaged by external factors. The system will move in the direction of offsetting this factor to achieve a new balance. So, the key to the Chatelier principle is to offset. Next, do you want to know the definition of balance? Balance is defined as the rate of positive reaction equal to the rate of reverse reaction. Then, concentration, pressure, and temperature affecting the reaction rate. Next, we are going to explore these three factors. 1. Concentration change. If you increase the concentration of a substance in the reaction, the balance tends to reduce the reaction of the substance. Taking the balance of hydrogen and carbon monoxide produce methanol as an example. Suppose we increase the concentration of carbon monoxide in the system. Using the Chatelier principle, it can be predicted that the system will proceed in a direction of carbon monoxide to offset this change, and the amount of methanol will increase to reduce the amount of carbon monoxide. 2. Pressure change. The pressure is also reflected in the direction of eliminating the balance factor. Take the famous Haber process ammonia reaction as an example. The coefficients on the left and the right side of the reaction are not the same. So, when the pressure is increased after the equilibrium, the reaction proceeds toward the smaller sum of the stoichiometry of the gas, reducing the amount of gas to weaken the effect of the pressure increase. Conversely, if the pressure is reduced after the balance, the reaction will proceed toward a larger sum of the stoichiometry amount of the gas to weaken the effect of the pressure reduction. However, when the coefficient and sums of the gas reactant and the gas product are the same, the system balance is not changed, but by external pressure changes. 3. Temperature change. In determining the effect of temperature on balance, energy changes are considered to be one of the substances involved in the reaction. For example, if the reaction is an endothermic reaction, delta H is smaller than 0, heat is considered a reactant and placed on the left side of the equation. Suppose a reaction is an exothermic reaction. If the temperature is lowered, the equilibrium will shift to the right, generating more heat to reduce the effect of temperature reduction. Next, I am going to teach a simpler method. There is a saying that more are sent to others, less are looking for others. Example: if A is more, then it will send to C or D, so the equilibrium will shift to the right. Or if D is more, then it will send to A or B, so the equilibrium will shift to the left. Is this a lot easily to remember? Finally, We have to practice the topic to see if we have learned it. Exercise. Haber process. Nitrogen and hydrogen generate ammonia. When the following factors change, the reaction will shift to the left or right. 1. Add nitrogen. Because of the increased amount of nitrogen. In order to balance this reaction, the reaction needs to proceed to the right, producing more ammonia to reduce nitrogen. 2. Decrease hydrogen. Because hydrogen is less, in order to balance this reaction, the reaction needs to proceed to the left to produce more hydrogen. 3. Increase pressure. The reaction proceeds toward a smaller sum of the gas stoichiometry, reducing the amount of gas to reduce the impact of increased pressure. 4. Decrease pressure. The reaction proceeds toward a larger sum of gas stoichiometry to reduce the effect of pressure reduction. 5. Decrease temperature. Because the reaction is an exothermic reaction, if the temperature is lowered, the equilibrium will shift to the right, generating more heat to reduce the effect of temperature reduction and increasing ammonia production.